All right, well, I'm not sure that you can hear me, but I assume that you can. The topic, as you can see on the slide and before, is what we're talking about, and generally this is referred to as slit scan photography, but this is a record of my experiences starting in the mid-1960s, and it has to do with improvised solutions. So as a youngster, I built models, and early on started to mess with my cameras, and I replaced the lens on this one. Not only did I build models, and later on when I grew up, I built these little sailboats for a while. But my love of photography won out, and I made many accessories that I couldn't afford, and I made them improvised in an improvised way. Even made an enlarger and a reflex housing for Leica. But my professional life revolved around scientific and technical photography, and my mainly high-speed photography. And these are some examples of what I did with my students. And I did some professional work as well. I worked on the Lee Harvey Oswald photographs, and also the O.J. Simpson photographs, and a number of consulting jobs and publications and recent exhibitions all over the place. But my inspiration to what you're going to see later on is George Silk. George Silk worked for Life magazine, and once I was asked to put together a thesis, a Master's of Fine Arts thesis, and I got inspired by George Silk. You can see the, I think, drastic change in my approach to photography before 1965 and after 1965. Before I was going to be a newspaper photographer, and after that I decided, I had the opportunity to change careers. There are a number of photographers who I'm wondering if you guys are listening to me. Here you can see Neil Leifer on the left. The diver looks like a regular photograph, but it's not. Photographer in Germany, Heinz Boguslawski did some work, Alan Zinn, a panoramic photographer, and Jerry Danzig also. Whoops. So I hit the wrong button. So you can see, I think, sort of a resemblance to George Silk's work. And then I did a lot of sports photography. And these are some examples. Around latter part of 1960, I started publishing. This is my first article on this basis, published in Popular Photography magazine. And then Camera magazine from Switzerland approached me for a cover, and then a big American magazine used my photograph on the cover once they had a fold-out cover. So just to get on track, thinking about slits, the thing to remember is that there are two types of shutters in the past. There was the focal plane shutter, and then there was a leaf shutter. The leaf shutter exposes all parts of the negative at the same time, but the focal plane shutter, as you can see on the Nickler map, is a slit that moves across the focal plane and exposes the film sequentially. The newest shutter is the digital shutter, the digital global shutter. So Henry Lartigue produced this photograph in the 1930s, I think, and it exploits focal plane shutter distortion with a 4x5 camera. The photograph obviously is distorted, and it's a result of him panning the camera at the same time as the car was going by, but not quite at the right speed. So you get distortion both ways, left and right. These are some of the cute things that we did with my students, exploiting focal plane shutter distortion. So what about if instead of moving a slit in front of film, we move the film beyond the stationary slit? So here is the setup. There's a slot. Behind that, the film moves. Now we'll put an image on the mask, and it'll be just a square. And the square is going to move from left to right across the slot. The film and image, in this case, are moving at the same rate. So eventually, this image moves across the slot, and you get a record. And the record, I think, as you would expect, would look just like the image should, which a square is a square. Now, if there are discrepancies in the speeds, the image moves slower than the film, then the result is a stretched out square, and if the image moves faster than the film, in that case you get a compressed result. So this is typical of slit scan, or what you'll see as strip photography. You have to match the two. The most, I guess, socially presence of these types of cameras is at racetracks. On the right, on the left, you can see the sort of an idealized illustration. There are horses on the track, and they're coming along, and the film inside of the camera moves. Now, the illustration in that illustration is wrong. The horse's image should be moving in the opposite direction that the horses are, but we'll ignore that for the time being. In any case, on the right-hand side, you see a photo for place, that's second place. Presumably, horse number 1 won the race, number 3 is second, and number 5 is, say, third. The question is that you might wonder is which horse came in fourth, either number 10 or number 5. Or that's number 6. So the answer, I let you for a second ponder that, but I'll tell you that the horse number 10 is fourth in the race, because by the time horse number 6 got to the slot of the camera, the neck of horse number 10 had already passed. So that line that you see there is not the finish line. It's one of a million finish lines that you could draw on here. That's put on artificially afterwards, just to please the public that there is a line. But the finish line is actually the slot on the camera. So if I were to ask you where is the finish line would be everywhere on this photograph. Any vertical line you care to draw. So this is a photograph of time, actually, and the image of the horses is reproduced as they cross the slot. Well, how do you make an improvised version of that kind of a system? Well, here you see on this film camera, you see I installed a slit in the focal plane, and to move the film, I advance it all the way to the right-hand side so the cassette is empty, and then I open the shutter and rewind the film. And rewinding the film causes it to move behind that slot, and eventually you run out of film. You try to make the movement as smooth as possible, and for that, improvised lever works better than trying to turn the little crank on the camera. So there you can see it. And I found through extensive research that number 2 pencils make the best levers. That's a joke. However, I can't see you all, so I hope that you got it. So what about going on a more advanced basis? Well, you can make a motorized version, such as this. The the motor now rotates the rewind knob in a more steady fashion than you could do by hand, and but the idea is the same. You have to have some means for rewinding the film back into the camera. Here's a more streamlined version of that rewinding bracket, and my students made these in my classes for many years. I'm not sure how many of them actually used it, but it was a project that we did. And here you can see some examples of so I don't know if you can, if everything is going okay. So these are some examples, and here is a train, a pretty long train. Yeah, something that you probably couldn't do with a regular camera. You need to look at that train over time. So what happens now if instead of moving the subject across the camera, you rotate it? Well, if you do that, in that case you generate a peripheral or a rollout photograph. So here's the setup. We put a piston on a turntable, and that will spin, and now you aim the camera at that rotating piston. Notice the number 2 pencil, and the slot is aimed at the rotation of the piston, and eventually as it makes a full turn, you record the whole surface of the cylinder. And when you print the negative, you end up with a 360, well, this is not 360, but it's almost 360 record of the surface of the piston. This is an industrial application, and it's been used for a long time in industry. But it's very little known. But it's used in forensics, it's used in archaeology, and anytime that you need to photograph the whole surface of a subject. So, you know, here's a more serious, maybe, application. In an archaeological sense, this spot was broken, and then it was being reassembled. And here you can see on the left the pot from one side, and on the other from another side. But what if you wanted to see all of the pieces all at once? Well, in that case, you can do what I just did with the piston. Spin it, look at it with a slit, and then you end up with a photograph that shows you the whole surface, all of the pieces, although some of them obviously are going to be distorted, because if you remember the original slide that showed you the setup, the image speed must match the film speed, and that's not possible in this case where the subject has a different diameter everywhere, because the belly of the pot is bigger than the top, for example. So, but besides taking this serious approach, how about if we do some fun things and photograph people on a turntable? Well, in that case, you make a rollout or peripheral photograph of the subject, such as this one. Happy lady who's getting dizzy turning on a turntable. On this case, the subject has made more than one turn and has changed expressions between the 2 times that it happened to be facing the camera. And you can have a lot of fun with this. But you end up generating negatives that are very long. And that's sort of a problem, which I'll address a little bit later. Now, we have right now have two things in motion. We have the subject in motion and we have the film in motion. But what if we, in addition to that, we also move the viewpoint of the camera? In this case, we'll move it from side to side. So the slot first looks to the left, then looks to the right, and in the meantime, the subject makes a full turn. And then you get something like this. This is not obvious right now, it just looks like a distorted photograph. But there is 180 degrees from one side of the picture to the other. And here we have a more creative presentation when we put a model on a turntable and do the same, and we end up with a person with 3 legs, right, and 3 arms, but only one head, and that just so happens that her face only was off to the side from the slot, and it only got recorded once. But she's made a 180-degree turn because the leg on the right is the same as the leg on the left. So, what do we do next? Well, now instead of rotating a subject in front of the camera, what about if we rotate the camera instead of the subject? In that case, you may get into panoramic photography. And here I am photographing with that improvised camera that you saw earlier. It's placed on a tripod head that rotates the camera, and there I am at Mount Rainier making panoramic photographs many years ago. So here is a scene that some of you may recognize. Those of you in Spain should have no problem recognizing this being Toledo. And for those of you on the southern hemisphere, here is another scene that some of you might recognize if it shows up. Here it is. And this is La Casa Rosada in Plaza de Mayo, and there is the famous Independence building. And it's only possible because you are making this photograph over time and not instantaneously. Instantaneously is what you do with a regular camera, but in this case you do it over time. If you take one of these 360-degree negatives and you blow it up, then you are able to join 2 ends together and make a 360-degree display of a particular scene. In this case, it's a street in my city, and it's hanging from a ceiling, and you can actually duck under this, get into the inside, and it's almost as if you were in the real location. And the display looks like this. It's a 10-meter long print, and then it's displayed as a hanging cylinder, and that's what you can get into. And at the time of this exhibition, I also had sounds of the city, and that made the presentation a little bit more believable. So, what do we do now? So now we might, I decided to make a camera that is very similar to a commercial camera, and that would be an automatic panoramic camera. And you'll see it right now. There's a scene of New York City, Times Square, I think it is, and at the very top, and it was made with the camera described in the middle. And you can see in the middle picture there's a slit in the back of the film plane, and the motor drives the take-up spool, in this case, within the camera. And you can also operate the camera manually. And I found that it's kind of fun to do that when you do it manually. The camera sits on a tripod. On the lower left, you can see a lever attached to the camera, and that is what you turn. But if you do that, and you do a 360-degree picture, invariably you get your armpit in the photograph every time. So here you can see the component parts, and the wheel on the bottom of the camera attaches to the inside depression on the platform on the lower right, and that drives the film, the sprocket, and that moves the film through the camera body. The amount of film that goes through the camera has to be proper for the lens that you happen to be using. So there's a little bit of mathematics involved in trying to figure that out, but it's not a big deal. You can also see the lever that I use to turn the camera by hand, and it generates pictures like this one. And you can see my armpit twice, well, on the two strips, but the people have changed positions with each rotation of the camera. And here's some panoramic photographs made with that camera. Interesting. Okay, here comes another one. And what do we have here? Here's the camera in action. So there's the camera in action, and then you make a still with this, and it might look something like this. This is out in Phil Show in Seattle, and at this point, what I'd like to ask you is if you would like to. Well, anyway, I built in a intermission. So if you want to get up and walk around, turn around, this is your chance to do it. And I have the next half of the presentation coming up. So, yes. Yes, I can. Yes. Can you hear me? Okay. And you can ask this. Hello? Yes. Yeah, that's a good question. I can give you sort of the theoretical answer, and that would be, let's approach it from another point of view. The smaller, the better. However, when it gets too small, there are optical effects, diffraction that happens, and that's not good. So you want to make it bigger than that. But if you make it too big, then any discrepancy between the speed of the image and the speed of the film leads to more and more blur. So it's a compromise, you know. Exactly. Right. Yeah. Yep. No. There are ways to figure that out. The exposure is a function of how wide the slit is and how fast the film moves. So if you have a 1 millimeter wide slit, which I like because it's a nice round number, you divide that by the speed of the film, and suppose the film is moving at 10 millimeters a second. In that case, your exposure time is 1/10 of a second. So there is a way to figure it out. Now, the question is, how do you figure out how fast the film moves? Well, there are easy ways of doing that too. It all depends on how fast you turn the rewind knob, how fast you're rewinding, if you're rewinding the film. Now, obviously, the film speed changes over time because the spool diameter gets bigger. So if you keep the rotation rate the same, film will speed up. Ignoring that, you can find what the average amount that goes through the camera each time you turn the rewind knob. And a 35 millimeter camera, it's about 50 some millimeters. So let's assume it's 50 millimeters. At the beginning it's a little slower, and at the end it's a little faster. In that case you can say, well, each time I turn the crank, 50 millimeters of film goes through. So if you turn the crank once a second, you're moving the film 50 millimeters a second. And if your slit is a millimeter wide, exposure time is 1/50th of a second. Make sense? Okay. All right. So, but it's all yeah. Yes. No. Yeah. I've only done 2.25 or 120 film and 35. I've not done 16 millimeter or real small format, no. But the principle is the same. Yeah. So that's kind of the technical part of it. Yeah. Any other questions? Any? You can ask. Puedes hacer la pregunta en español si quieres. Si quiere. Ok, muy bien. Ok, volvemos a la presentación. Ok, bueno, here we are. Intermission over. And, okay. Can you hear me? To make enlargements, is that what you're reading, right? To make enlargements of long negatives, you make a strip enlarger, right? It's not unusual to make exposure times that maybe last a few minutes, but you generate an awful lot of film, and I'm talking mostly 35 millimeter, but anything. So now you have a negative which is, let's say, 10 meters long. How do you make an enlargement? Well, there are new enlargers that you can accommodate a 10 meter long negative. But you can deal with that by moving the negative in the enlarger past a slit in the enlarger head, and then you move the paper at the baseboard of the enlarger at the speed that the image of the enlarged negative moves. And then eventually you run out of paper or out of a negative, and you end up with a negative. Okay, here you see the enlarger head. Forgot to mention that. You can see the enlarger. You can the enlarger head has a means for moving the film. You can see that on the lower right-hand side. There are a couple of Polaroid rollers that I've motorized, and they pull the film through the enlarger head past the slit. The slit, in this case, I made out of red filter material, the mask I did, so I could kind of see what was happening at the easel. And then at the easel, I used an ectomatic processor that I modified to run at a variable speed to pull the paper underneath. And the paper has to move as fast as the enlarged image from the enlarger head. So you don't make a print instantaneously or in a short time. It takes a long time for that paper to go through. Now, really long enlargements that were maybe 10 meters in length, the difference between the time that the beginning of the enlargement was made, and the end could easily run into a half an hour to an hour because you need time to make it. Even though instantaneously the time for the exposure probably would have been maybe 10 seconds. So the paper moves fairly slowly. Anyway, it takes patience like almost anything else. So here's the setup in my workroom at the time. It's a Lights Below enlarger that I've modified slightly, and the Actimatic processor down below to draw the paper. Everything is run by variable speed motors, the paper and the negative as well. And to match the paper speed with the image speed at the easel, I just look at the moving grain of the negative at the easel, and I would put dots with a pen on the moving paper, and then adjust the paper speed so that the dots that I put on the paper and the grain of the enlargement would move at the same rate, so that I'd know that I matched the two properly, rather than trying to use math to figure it out. That was a very good way of deciding how fast to move the paper. So then you end up with paper prints that are, long. Now I must say that I'm not the only one who dreamed up of this. After I had made my enlarger, there were companies in Italy that made enlargers that worked this way. They and today's digital prints are made that way, a little piece at a time. So so much for enlargers. So where am I? Well, what about exploring other materials besides film? Well, film in a way. Well, Polaroid. What can you do with Polaroid? Well, the first thing to do is to consider what a Polaroid pack film, how it works in a camera. Well, in the camera, there's this pack, and there's the film that goes into it, and I covered the aperture gate of the Polaroid camera with a opaque mask, leaving just a very, 1 millimeter slit at the far end of the pack. And then when you pull on the white tab, what you're actually doing is pulling the negative to the right, in this case to the right, as the tab is moving to the left. So they're attached to each other. But the interesting thing is that in the process of the film moving from the front to the back, it now passes past that slit and gets exposed in the same manner as it did in the 35 millimeter camera. So here I loaded that Polaroid with film, and the first thing I did was to check the system. I tend to do this because I figure from mistakes comes knowledge, and that means if you make a mistake, you figure, well, I better not do that again, and things get better. So in this case, there's this model train going by on the track, and the camera has the mask in front of the film. In this case now, the film is going to be pulled out by that motor, and it's pulling on a string, which it pulls on the paper, and it pulls it from the front to the back. And because the pulling power of the motor is more uniform than your hand, you get the results that you see on the lower right. The one on the lower left is what happened by pulling the paper by hand. So you say, well, what can I do with this system? Well, I applied it to making portraits. But before we see those, here's a more descriptive picture of the layout. At the top, you see the camera that I actually eventually put together. I took this Polaroid camera, cut off the front, and moved it over so that the lens would be in front of the slot instead of to the side, so the camera can be pointed straight. So there is the 1mm slit in the pack. The white tab is connected, as you can see, around the far side of the pack, and the clamp is clamped to the white tab. That pulls on the pack, the white tab that's connected to the film, and so this kind of works. I mean, actually, I didn't really change the camera too much. Oh, I did take the shutter out because you don't really need it. The exposure is controlled by how fast the paper moves or the film moves behind the slot, and then you can make peripheral portraits like you could with film. They're not very long, but they let you explore the system and think about possibilities. So you say, okay, but we are now in the digital age. So what do you do in digital age? Well, find yourself a linear array to begin with, and then you mimic the film approach. Well, where can you find a linear array? That's pixels. You can find them in a hand scanner. These are out of vogue these days. So anyway, at the time that I asked this question myself, I said, well, do I find one? Well, in a hand scanner, and these are things that you can draw over a drawing or some text, and it records whatever it rolls over. If you look inside, you take this apart, you look inside, there is this linear array that you see, and that is an indication that this potentially is useful to make a system that works just like the film does, in a way, quite a bit better. So here you can see the dismantled scanner, and inside of the camera you can see the linear array that I installed in the focal plane of the camera. So this all obviously then connects to a computer, and the setup kind of looks like this. In this case, the camera is going to be used to photograph a bullet. You might think of it as a forensic application, and it is a serious forensic approach to photographing bullets to identify them. In this case, however, the bullet is sitting on a turntable, and its image is placed on top of the linear array. The linear array then transmits the information to the computer, and the whole setup is like this. You can see the hand scanner guts on the lower right, the computer display of what the camera saw on the screen, and the printer, which is printing out the image of the bullet, which looks like this. Now, it is maybe on a creative point of view kind of dull, but for a forensic application it's very, very appropriate. You can see those little white tabs on the bottom of this image, and those tell you that between two of them, the bullet has made one turn, one revolution. So here is the piston that you saw earlier, done with the digital camera. Now the piston was not centered quite right, so the holes get a little distorted, but nevertheless, the details of the piston surface are clearly visible, and it becomes useful as a forensic or an industrial tool. But in my case, I like to explore human applications, and making these peripheral portraits with a digital system obviously saved me a lot of Polaroid. Polaroid at the time was very nice to me and gave me quite a bit of material, but in this case I don't have to use up any expendable film. So here's one, here's another one, and I've had opportunities for people to be photographed in this fashion at various conferences and meetings, professional meetings, and I usually have lines of people that are lined up waiting to be distorted. So what else can we do now? Well, what about DSLR cameras? Well, and this is it's kind of a recent interest of people, because they have a DSLR and they say, well, I'd like to use my camera to do this kind of stuff. Well, how do you do it? Well, one way is to put a mask in front of the camera, and in this case it'll be photographing a racetrack coming down the track there. The camera is aimed so that the image of that slot, which then is looking at the cameras, moves from one side of the gate of the camera to the other. And this is accomplished by panning the camera, just turning it from one side to the other. And it's important when you do this to consider the same thing that panoramic photographers do, and that is to rotate the camera about the nodal point of the lens instead of the tripod socket. And you can see that just in a second. And this is the result of that camera. I, at one point, claimed that this was a first of anybody using a digital SLR to make a photo-finished photograph. I'm not sure that was right or not, but you can figure it. Tell me if not. So, besides using a mask in a lab setting, I've made this box, which you can then aim the camera into, have a slit at one end, pan the camera from one side to the other, and make the DSLR work as if it were a slit scan or a strip camera. Here you see the contraption, the part that allows the camera to move or rotate about a point other than the optical axis or the nodal point. Here's a diagram of the box. I think you can easily figure out what it's like. So anyway, there's the illustration. Let's see. This is the actual setup of the system. Hold on just a minute. So the slit, obviously stationary. The subject is rotating with the digital system. The subject can rotate either clockwise or counterclockwise. You just get a reversed image if you go the wrong way. There's our DSLR solution. And here we go. Okay, so we have here we're going to see what one might call a slightly specialized application where a company asked me to do a rollout or a peripheral photograph, like a piston of detail on a piece of pottery. So the system has applications all over the place, in ceramics and as well. So this was the challenge. There were 4 cylindrical pots and 1 teapot. The cylindrical pots presented no real problem. You just put them on a turntable, you spin them, you move the film behind the slit at the right speed, and you end up with a proper photograph. So there's the pottery, the camera, and you can see the slit in it. In this case, I used a motorized film advance mechanism that's on the lower right, but still, its function was simply to move the film at a constant speed through the camera. And then you end up with a result that is just what you want. You can make a decal out of that and put it on industrial production of these pots. The problem was the teapot. The other ones were cylindrical, so the diameter was constant from one area to the other, but the teapot is tapered, so its circumference at the top is shorter than the circumference at the bottom. Well, if you try to make a peripheral photograph of a teapot like this, you'll either stretch the top and compress the bottom, but you can't match the speeds everywhere. You might say, well, I can tilt the camera. Well, the film still moves at the same speed at the top and bottom. So what you need to devise is a system where within the camera, the film will move faster where the bottom of the teapot is located, and slower when at the top, where the top is. Well, how do you do that? Well, you could use rubberized film. No, that doesn't exist. So you devise a camera to solve the problem. And here's the camera eventually that I made. So the camera has a motor that rotates the film. Yes. Okay, so I will continue, and here's the film plane for this camera. This is what it looks from the front and then the back. There's a teapot. There's a camera that's rotating the film during the exposure time, and it makes a negative and a print like this. This can be matched to the teapot. Or you can photograph people, and that's what and flowers and so on. If you use the camera in a panoramic mode, then you generate negatives like this, which generate images like this, and you say, well, what can I do with this? Lampshades, for one, skirts, bras, etc. So, thank you all for listening, and bye-bye. You can contact me at these locations. Email is great. Thank you very much for your attention, and I hope I haven't, yes, many years, many years. And thank you all. Muchas gracias.